Alright, quick video here on elements, compounds, and mixtures. This comes into how we classify matter into different categories. So these are our three major categories of matter for our purposes this year. So when we talk about matter, matter can be divided into elements, compounds, and mixtures. And an element is what we would classify as like a pure substance, meaning that it only contains one kind of atom, where a compound would be consistent of two or more different elements that are chemically combined together by chemical bonds. So the resulting substance of a compound is different, has different properties than the elements that make it up. And then a mixture, which is two or more substances that are physically combined, meaning they're in the same general location, but that there's no chemical bonds holding the substances together. You can have mixtures of elements, you can have mixtures of compounds, you can have a mixture that contains some elements and some compounds. You can even have a mixture of mixtures. So these can be a bunch of different types of mixtures that can come into place here. When we talk about elements, because they're all the same type of atom, they really can't be separated. It doesn't really matter whether the means are chemical or physical, but they simply can't be separated into different groups. They're all the same item here. So a compound, the atoms that make up a compound can be separated from each other, but this would have to be done chemically because you're breaking the chemical bonds that hold atoms together, and you end up with a different substance. It's like if you took a whole glass full of water and you were to break apart the water to get a hydrogen gas, which is H2, and oxygen gas, which is O2, you end up with a different substance than you originally started with. This would be a chemical change because you would have started with one substance and ended with different substances. So the separation of the components in a compound can only happen chemically, whereas the separation of the components in a mixture can be separated from each other physically. It requires no chemical changes to occur. So we're going to talk a little bit more about in this video about elements and then about compounds, and then there'll be a separate video there for mixtures, maybe even 2 videos on mixtures. So make sure you come back and check those out. So when we talk about elements, this is the periodic table of elements, and it lists all the elements that exist. Now there are some of these that are they begin with UU. These were like placeholder elements for elements that had not yet been discovered or even theorized. And at this point, all of this entire row here is all complete with elements that have just kind of recently been discovered or made by humans. So there are these UU things are all gone and they're replaced with other names, and these empty spaces are all filled in now. But this is the periodic table of elements, and it lists all the elements that we know, as well as a whole bunch of information about those elements. Just kind of note here is that this row here that starts with LA and ends with YB, that belongs in this space here where the little single star is, and then the double star, this space, this whole row fits into. These were just kind of pulled out and set to the bottom because these have a lot of properties and alike with each other, and these have a lot of properties like each other. But they also, it makes the periodic table a little more reasonable to use, so it's not super wide. So when we talk about elements, elements can be broken into 3 categories themselves. Elements can be either metals, and some just common properties of metals is they're lustrous, meaning they're shiny. They're good conductors of both heat and electricity. They're malleable and ductile. This is also the most common type of element. More elements are metals than are anything else combined. So elements are definitely the most popular type of, or metals are the most popular type of elements. And this makes up the entire left-hand side of the periodic table. So this whole area over here is all metals. It's like everything on this side except H. And like all these things at the bottom, those are all metals. Most of these are all metals. Al is a metal. It didn't quite fit in my circle there, but most of the elements in the periodic table are going to be metals. Now there's also some elements called metalloids. These are kind of the halfway point between metals and our other category, which is non-metals. And these are things that are called semiconductors. They kind of, some of them have the ability to conduct heat and electricity in some ways, not in other ways. So these are what we call semiconductors, semi meaning like kind of or almost conductors. These have some characteristics of metals and some characteristics of non-metals, and metalloids are not always the same. So one metalloid might have one characteristic of metal, but then a different characteristic of non-metal, and that might be the exact opposite of from a different metalloid. So Just metalloids in general contain some characteristics of metals, some characteristics of nonmetals, although what those characteristics are not always consistent. We would say these are like somewhat malleable. They're somewhat ductile. Some are very malleable. Some are very ductile. But that's just some of the properties. They're somewhat shiny to see. Most of these are kind of shiny to see, but not always. And then these are located between metals and nonmetals on the periodic table. So metalloids are kind of our toughest group to situate here. And these guys are this right along the stair step of our periodic table. So when you look at the periodic table, there's like a bold line here. That's what I like to call the stair step. And the elements just on the top of the stair and the element just on the bottom of the stair are metalloids. The only exception being Al, aluminum. That's classified as a metal. But the other ones like boron, silicon, germanium, arsenic, antimony, these are all going to be metalloids. Now, nonmetal is our last category of elements, and these are things that are dull. They're poor conductors of electricity and heat. They're brittle, meaning that they crumble or break apart. They're not flexible. They're non-malleable, non-ductile, and these are the elements that are on the right-hand side of the periodic table. It also happens that pretty much all the metals are going to be solid at room temperature. Generally, our metalloids are often solid at room temperature. Generally, our nonmetals here, a lot of them are gaseous at room temperature. So that's kind of something else worth noting. So if you kind of took a periodic table that you picked up or that you printed out, and you can kind of color it in like this, so you color in one color for all the nonmetals, one color for all the metalloids, and then you can leave everything else as nonmetals, or all the metals rather, all the other things that are left uncolored. You can just leave them uncolored, or you can color them in a third color if you want. That's just a lot more stuff to color in. But you can do this, and we'll kind of come back to this periodic table a lot. So if you didn't pick up a periodic table in class, or if you haven't been in class, you should print one out and color that in as so. And then we do want to talk about compounds here. So compounds are made up of different elements that are chemically combined together. So there's a chemical bond holding the atoms together. So the components are elements. And then the elements that make up the compound no longer have their original properties. Like oxygen is a gas at room temperature, and hydrogen is a gas at room temperature. But when they come together to form water, they're a liquid at room temperature. So that is like a totally different aspect of a totally different property for the compound water versus the elements that make up water. So the elements give away their properties. And these are very, very specific ratios. Like water has to be H2O. It has to be 2 hydrogens and 1 oxygen. You can't have a compound that has that's water that has 3 hydrogens and 4 oxygens. It doesn't work that way. So you have a very, very, very specific ratio of the components that make it up. For instance, H2O is water, but H2O2 is hydrogen peroxide. You need water in order to survive. You need to drink lots of water. But if you drink H2O2, you'll get very, very sick. You wouldn't want to do that. So these are, 2 different compounds that contain the same elements, just in different ratios, and that makes them entirely different compounds from each other. NaCl, sodium chloride, this is table salt. But it has to be 1 Na, which is sodium, and 1 Cl, which is chlorine. Has to be in that ratio. And then there's like CO2 is carbon dioxide. And if you just had CO, that would be carbon monoxide. And they're, again, very different substances. They have some similar properties, but they also have some very different properties. So these are the formulas that represent the ratio of the components. H2O means 2 hydrogens and 1 oxygen. H2O2 would be 2 of each, hydrogen and oxygen. NaCl would be 1 Na and 1 Cl. CO2 would be 1 C with 2 O's for oxygen. So these are compounds, and they come to that very, very specific ratio. So that's the quick rundown on elements and on compounds. And then our third classification, mixtures, there will be some follow-ups to check out, some separate videos to check out. All right, have a good one.